All right, all right, all right. What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, solving absolute value equations and inequalities, we are going to continue our notes from before. So, let's go. So, previously, in a previous video, we talked about the extraneous solutions, and we also graphed and solved absolute value equations. So there was one, possibly two answers, or maybe even no answers. So these were all equations that we were solving. So similar to that, we're going to take a look at the inequalities. So now when you take a look at an inequality, you'll know it's an inequality because this little thing right here that you'll notice right there or right there, that's an inequality symbol. So less than, greater than, or it could be less than, greater than, with an equal to underneath it. So when you first take a look at these, you want to analyze, see what's going on here. So if you have this, the absolute value part is already isolated, the ax plus b, that part is between. So I want you to write the word between here, c and negative c. And a lot of times you'll hear math teachers, we will refer to this as an and statement. So an equivalent version of this. So the statement, when you go to solve these, you'll take that ax plus b part. So you're going to write that kind of in the middle, and then you're going to have less than c right there. But over on this side, you're going to write the opposite, negative c. Because if you think about a number line, negative c comes before positive c. So that will be the equivalent mathematical statement that we'll write when we get ready to solve these. And when you graph them, they're always the pictures are all going to look the same. They're either going to have two open dots connected, or they're going to have two solid dots, and they're going to be connected. Now that's going to determine if you use this symbol or this symbol right here. So those two symbols are going to be the ones that will dictate which way the graph will look, whether you have open dots or closed dots. So on the other hand, we could have one where that initial inequality symbol is flipped around. So ax plus b is outside of or beyond that c and negative c. And a lot of times you'll hear this referred to as an or statement. So when you go to set this one up, the equivalent statement on this one, you kind of split it in half like we did for the equations. And on one version, we're going to take the exact same thing. We're going to have ax plus b, and that's going to be less than c. And we'll solve that and blah, blah, blah. And that'll give us one possible solution. Now the other one, this is where you got to be really, really tricky. Be careful. So you'll have ax plus b, but you'll flip the inequality symbol, and then the value of c is now going to switch and become negative c. So you'll solve each one of those simultaneously as we go down through this. Now this picture though, because it's an or problem, so you're going to have either this picture, so they're both going to start out with two dots, only this one, they go outside. They go to the left and go to the right. Now again, that's going to be determined if you have this symbol, or if they're going to have solid dots going to the left and going to the right, so if you have this version of the symbol. So the inequality symbol will kind of dictate what you got going on there. So when we look at these, let's check them out. So x minus 8, the absolute value of that is less than 3. So when you write it as a compound inequality, that just means you write it as without the absolute value bars. So I'll have x minus 8. Now notice the symbol is less than, so it's going to be less than 3, and then we put that over there and flip it and make it negative 3. On b, same idea. We'll have x plus 5. The absolute value of that is less than or equal to 7. But then on the other side, on the left side, we'll have negative 7. So that would be an example of how to write that as a compound inequality. Now notice example C and D. The inequality symbol, whether it's that version or that version, they are both flipped compared to A and B, which means we got to do things a little bit different. So we're going to have two statements here. So the first one, remember, keep it the same. X plus 2 is greater than 9. Or, so write the word or. And then we are going to have x plus 2 is less than a negative 9. So when we go to set it up, that's how we're going to set up. And then you would check ourselves. Now, do we have to solve it? I forget it. Oh, it just said rewrite. So we rewrote it. That's what we do. Now, if we're going to solve it and get fancy, we would have x is greater than, oh my gosh, what's 2 taken from 9? Yeah, 7. Or if we take 2 away from negative 9, we'd have negative 11. So that's what that would look like. Now I'm going to throw a picture in while we're at it too, because see these two values right here? Check ourselves. It's so cool. So we would have this. Now here we've got two values. One is negative 11. The other one is 7. So we'd have to be sure we put them in the correct numerical order on the x-axis, right? Because you'll see this coming up here in a moment. Now, based on the symbol, I'm going to have open dots on both of these. Now, if I want x's to be greater than 7, that's going to go this way. Like the numbers 8, 9, 10, 11, 12. They're all greater than 7. However, if I want numbers less than negative 11, then I would just go this way. Like negative 12, negative 13, negative 14, and negative 1 million. They're all on that side. So graphically, that's what our picture would look like. Now, for example D, same kind of idea, right? Just take our time, setting it up. So we'd have x minus 6 is greater than or equal to 1, or x minus 6 is less than or equal to negative 1. So remember, flip both the inequality symbol and change the sign of the number. So I'd have x greater than or equal to, what's 6 and 1? That's right, 7. Or I could have x is less than or equal to negative 1 plus 6. Ooh, that gives me 5. So these two values, they're not too far apart. But again, if we were to graph them on a number line, so here we go on our little number line. Again, 5 comes first, and then 7. Now both of these are solid dots. So if I want x less than or equal to 5, solid dot there, and those are the numbers that are smaller. And then x greater than or equal to 7, going to the right, is larger. So that's what that would look like graphically. We didn't have to do that, but we're just going extra because we love math. That's right. So that's going to lead us in here into example number 7, right? So let's go. Solve an absolute value quantity. First thing you're going to do is isolate the absolute value. Isolate the absolute value. I'm just going to abbreviate that. Abs, and then val, u. Now after I get done with that, second step, we're going to rewrite using an. So that'll depend on whether it's an and problem or an or problem. And then last thing, you just got to solve it like we would normally solve any inequality. So let's check this out. For example number 7, well, the absolute value, I'll call that the blob. This blob, there's no numbers in front of it, like a constant, and there's no numbers after it, like we were adding or subtracting something. So that's already isolated. So that's pretty cool. So now we just have to then analyze what symbol is that right there. So that's a greater symbol, which means of the two types, that is going to be the one where we set it up. And this is always the most important thing, is after you isolate it, write the equivalent compound inequality. So this one is going to be 3x minus 2 is greater than 18, or 3x minus 2 is less than negative 18. And then again, just take your time as you solve these. So you're going to have 3x is greater than, if I add 2 to both sides, I'll have 20. So x will be greater than whatever 20 over 3 is. All right, so if that was 21 over 3, that'd be really nice because it'd be 7. But it's not, so we got a fraction to deal with. Oh my gosh, but it's close to 7. Now on the other side, if we did the same thing, we added 2. Let's do 3x is less than, added 2, you get negative 16. X is going to end up being negative 16 over 3. So again, these are both values that are really close, but don't work out to be whole numbers. So now it's pretty easy. One's negative, one's positive. So on the number line, we could put them wherever we want. So I'm going to just say negative 16 over 3 is there, and say 20 over 3 is somewhere over here. Now once we have those two values, this is an OR problem. So remember, ORs. So x is greater than 20 over 3, so we would have an open dot right there at where we declare that to be, and we would go to the right. And then for the other part of the solution, x is less than negative 16 thirds, we would have an open dot above that value, and we would shade or go to the left. So that's that guy right there. Not too bad. All right, now as we get into example B here, I want you to make one little correction. Just make it a little bit easier. We're going to take that 6. We're going to make that a 5. All right, so that'll just help things go a little bit simpler. Now, as you do this, first thing we want to notice is that the blob, the absolute value, is not isolated yet. So we will start by adding 1 to both sides. When we do that, we get 2 times the absolute value of negative x plus 5 is less than or equal to, if I add 1 to both sides, I'll get 6. Now, dividing both sides by 2, we'll get the absolute value of x, negative x plus 5 is less than or equal to 3. Now that I've got this part set up, now I I'm going to have negative 3 is less than or equal to negative x plus 5 is less than or equal to positive 3. From here, you're going to add 5 to each one of those sides, or subtract 5. So if I subtract 5 from the left side, so negative 3 minus 5, we're going to get negative 8. And on the right side, if I do 3 minus 5, that will give me negative 2. Now here's where you got to be really careful, right? Because we notice right in there we have a negative with the x. So we're going to divide everything by negative 1. Now, not only when we do that, so there's going to be kind of two parts to this little tricky bugger. So when we divide by negative 1, we'll get an x there. The signs will switch. That'll become 8, and that'll become 2. However, the signs aren't the only thing that switches, so do the inequality symbols. But this is not mathematically correct. You got one more step to go. Because when you write this, yeah, the x has to be in the middle. But you want the biggest number, the largest number of the two that flank that value of x. So these guys right here, I'll go ahead and highlight them, the 2 and the 8. You want them to be in correct order from left to right, numerical order from smallest to biggest. So we're going to rewrite that. And as we do that, we also then flip the symbols kind of back to where they were. So the 2 will go on that side, and the 8 will go on that side. So this would be the correct solution written for this problem. So be really careful when you do that, because that's a very common mistake. I see that all the time where people go, whoopsies, and they forget to do that. So that last step here, let me just make that a little bit bigger on it. Then you want to make sure that you have everything written correctly there. So you're going to have x, and then on the outside is going to be 8 on the right and 2 on the left. So once we get that, we can see, yep, it's an and problem. So it doesn't always matter where, as long as you notate it on your number line. So 2, 3, 4, 5, 6, 7, 8. So maybe 8's there. Now, based on these symbols, solid dots, bro. That's right. So solid dot above the 2, solid dot above the 8. That's an and problem. So anything in between, and we good. All right. So that's this guy right here. Now we've got one more example to do. Example number 8, and then we're done. We out. So this one, again, it's a real tricky one in a sense, because we got to make sure that we read very carefully. And when you read this problem, both of them look very similar. Manufacturer has a 0.6 ounce tolerance. Now let's talk about this word tolerance. The word tolerance means how much above or below something can you go. You have a little bit of wiggle room. And in this case, it's 0.6 ounces. So we can go like 6 ounces above or below a certain value, and we would be okay. So now this salad dressing is 16 ounces. All right, so you can go 16 ounces, maybe a little higher, a little lower, and that would be an acceptable range for this bottle of salad dressing. Right? Now, here's where we got to do the reading part. It says, write and solve an absolute value inequality that describes, and this is a key word right here. So I want you to underline this, acceptable. Acceptable volumes for 16 ounces. So if it's acceptable, it's give or take that 0.6 ounces. So my absolute value inequality that I'll write for this problem, so we take whatever the weight of the bottle is minus the 16 ounces. So the absolute value of that has to be within 0.6 ounces, so 0.6. So that would be my inequality that I would set up. Now, similarly, so that's my absolute value inequality. So let's take a look at the other side, the other example here. It says manufacturer tolerance of 0.36 pounds for a bag of potting soil that's advertised as 9.6 pounds. Write and solve an absolute value inequality that describes unacceptable. So that means it's either going to be outside of that range. All right, so this is where it's slightly different. So we'll set it up kind of the same way. We'll still have x minus and then 9.6 pounds, right? So we'll take the absolute value of that. But since it's unacceptable, it's going to be more than whatever that tolerance is. Oops, come back here. So that piece would then be greater than or equal to whatever the tolerance is, which in this case is 0.36. So that's how you would set up each one of these absolute value inequalities for these two problems. Now that we've got them set up, now we just kind of analyze what type they are. In the first one, and I'll just kind of write this here on the line, you'd have negative 0.6 is less than x minus 16 is less than 0.6. So that would be for the one on the left. Now the one on the right side, because it's gray tour, so that's going to be an or problem, so we're going to have two pieces of this bad boy. So you'd have x minus 9.6 is greater than or equal to 0.36, or, so here's the other part of it, right? Because you got that or, so then we'd have the same thing, x minus 9.6, but then we'd have less than or equal to, because remember, we've got to flip that inequality symbol and make the 0.36 negative. So negative 0.36. So those would be the two ways that for each one of these. So it's just a reading piece, and make sure you key in on those two words, acceptable or unacceptable, and notice which inequality symbol is used for each. Now, when we take a look at this last piece, check this out, man, right? How are the absolute value equations and inequalities like linear equations and inequalities? Same ideas. You know, we use the same processes. So you're going to isolate and solve. And just like absolute value equations and linear equations, you would get one answer in linear equations. And in absolute value equations, you get one or two, or maybe none, depending if some are extraneous. So you're going to isolate and solve. Now, with the inequalities, same thing. You'll get a range of answers. You'll get a range of answers. So when you look at these, you'll isolate them and solve them very similarly. All right, so that's it. I know this video is a little bit longer. Thank you guys for hanging in there. I appreciate you for doing that. There's a lot in this one, I know. But congratulations on hanging out for that. So that is the rest of our notes for this. Again, if you ever have any questions, be sure you stop by, see any of your teachers. And as always, thank you guys so much for watching. I appreciate you, each and every one of you. Much love to you. Get out there and have an absolutely amazing day, because there's simply no good reason not to. And I'll catch up with you soon, Cub Scouts. Peace out.